We've learned three ways now to determine if two vectors are parallel. One was if we take the dot product using this formula, u dot v is the magnitude of u times the magnitude of v times cosine of the angle between them when I put them in standard position, meaning I tie their tails to the origin, or I put their initial point at the origin. So if they're going in the same direction, then the angle between them is 0 degrees. Cosine of 0 is 1. That simplifies our formula to the cross product equals the magnitude of u times the magnitude of v. We can verify vectors are parallel and in the same direction if this is true. If the angle between the two vectors is 180 degrees, meaning they're pointing in different directions, then the angle would be 180 degrees, and cosine of 180, if we know our unit circle, is -1. So -1 times the magnitude of u times the magnitude of v. If we have this, we can verify that the vectors are parallel and in opposite directions. A second way we learned to figure out if vectors were parallel was to investigate this type of relationship. If u is equal to some constant, that's a scalar multiplier of v, then the vectors are parallel. For example, if u is 2, 4, 6 and v is 1, 2, 3, I can do 2 divided by 1 is 2, 4 divided by 2 is 2, 6 divided by 3 is 2. Because all three ratios came up the same, it would be a ridiculous statement to say that u is equal to v, because u is bigger than v. But because these were all 2, I can say 2 of these is equal to 1 u. 2 of the little guys equal 1 big guy. I have met this requirement, therefore the vectors are parallel. A third way to tell if vectors are parallel is to examine the cross product. Here it is. If u cross v is equal to 0, then the vectors are parallel. If I gave you these same two vectors, u is 2, 4, 6, and v is 1, 2, 3, when I do the cross product, want the i's cancel the i's, want the j's cancel the j's, want the k's cancel the k's, make sure you subtract the j's. You'll get the 0, 0, 0 vector, which we can just call the 0 vector. So u cross v is equal to 0, means that the vectors are parallel. If you see this result, the vectors are parallel. As we saw earlier with our principles, u is always going to be parallel to u, so our answer there will be 0. And of course, vector v is parallel to vector v, so our answer there is 0 as well.